Hi guys, my name is Melissa, and in today's video we're going to be talking about a topic called looking for a pattern. And so basically in this video we're going to look for patterns for different numbers and different problems. And so to get started, we'll look at the first problem. So it says complete the number patterns. And so this is kind of like skip counting. You can think of it like skip counting, but for some of them it might not exactly be skip counting, because skip counting is when we add the same number for every single step. But for patterns, it can be multiplication, division, and many different types. So if we look at problem A, we've multiplied 2 to get from 1 to 2. Then we multiplied 2 to get from 2 to 4, multiplied 2, and multiplied 2. So we see that the pattern here is multiplying 2. And so the next number after 16 would be 16 times 2, which is 32. And then the next number would be 32 times 2, which is 64. Now let's look at the next example. So in problem B, we're adding 1. And then we added 1 again. But then now from 5 to 8, we added 3. And then from 8 to 7, we added -1. So we subtracted 1. Then from 7 to 16, we added 9. And so it seems hard to find a pattern like this. So we'll try to find a pattern in a different way. So it can be a combination of So it's not always just multiplication. It can be multiplication plus addition, or multiple different types. And so to find a pattern here, so from 3 to 4 we added 1, or it can be So if you look at this, you don't always have to go from, I know that for right now, some of you guys might not be able to find the pattern for this, but if you look carefully, it doesn't always have to go from one to the next. It can also go in order of 2s, it can also go in 4s, as long as it's a pattern. And so if we look here for the odd numbers, we're increasing the odd numbers by 2. 3 to 5, 5 to 7, 7 to 9, 9 to 11. But if we look at the even numbers, we're multiplying by 2. 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. Then our next number is going to be odd numbers, so we add 2. So it's 9 plus 2, which is 11. And then for even, we're going to multiply 2, so 32 times 2 is going to be 64. Then for C, we have 0, 3, 8, 15. And so we're adding 3, then we added 5, added 7, added 9, and so the number that we're adding by increases by 2. So the next one we're going to add by 11, so that's going to give us 35. Then we're going to add 13, so it's going to give us 48. And then we add 15, which does give us 63. Then we'll look at problem D. So we have 6, 1, 8, 3, and so on. And so to get from 6 to 1, we subtracted 5. Then from 1 to 8, we added 7. From 8 to 3, we subtracted 5. From 3 to 10, we added 7. So it's a pattern of subtracting 5 and adding 7. So the next one is going to be subtracting 5, so we have 5. Then we add 7 to get 12, subtract 5 to get 7. And so next we're going to add 7, and we're going to get 14. Then we're going to subtract 5, and so that's going to give us 9. Now let's look at problem E. So we have 2, 3, 5. So to get from 2 to 3, we added 1. 3 to 5, we added 2. And so the next one we would assume is adding 3. But sometimes this pattern might not always be. It's always kind of hard to figure out a pattern with just 2 numbers, but then we do have a 17 here, so we can kind of check if our pattern is correct or not. So let's try. If we add 3 to 5, that gives us 8, and then we add 4 to 8, so that gives us 12. Then we should add 5 to 12, and that does give us 17, so this pattern was correct. Then we add 6 to 17, and that gives us 23. And then next we have problem F. So to get from 3 to 5 we added 2, 5 to 6 we added 1, 6 to 10 we added 4. And so it seems kind of hard to find a pattern here. But then again, if we look from, if we skip 2 numbers, then we add 3, and so we're skip counting by 3s. To get from 5 to 10, we're adding 5, 10 to 15, adding 5. So we're skip counting by 5s for the even terms, and we're skip counting by 3 for the odd terms. So for the odd term, we have 3, 6, 9, 3, 6, then 9, then 12. And for the odd terms, we're going to skip count by 5, so it's going to be 5, 10, 15, and 20. Now let's look at problem G. So we have 7, 11, 19. So to get from 7 to 11, we add 4. From 11 to 19, we add 8. And then to get to 67, we had skipped 2 steps. So if our pattern is multiplying the number we add by 2, then by pattern, we should have added 32 plus 16 to 19. That is 48. 48 plus 19 is 67. So we can confirm that our pattern is correct by looking ahead. And since we confirmed that the pattern was correct, we're going to fill in this blank space. So 19 plus 16 is going to give us 35. And then 35 plus 32 we confirmed was 67. Then the next number we should add would be 64. And adding 64, that would give us 131. Then we're going to add 128, so it's going to give us 259. Now let's take a look at problem H. So we have 8 to 12 and 12 to 20. So we add 4, then we add 8. So naturally we would add 12 since we're skip counting by 4s now. So that's going to give us 32. So if we only have, we're not skip counting by 4s. So for this we have two options since we don't know the answer. If we're only given this, basically we can think of this as, oh, we add 4 to the number we add 4 continuously to the number we add, so we can do plus 12, plus 16, and so on. Or another way to approach this is we multiply it to the number we add, so it can be plus 16, plus 32. And so since we don't have information about what it is, since we lack some numbers at the end, usually problems will give you some more information. But for this problem, it was multiplying by 2, but then I know that it is hard to find that without any other numbers given. So in other problems though, in your school or when you solve other problems, they will give you more numbers. And so then we would add 16. So that would give you 36. And then we add 32. So that would give us 68. And then we add 64. So that gives us 132. And then next we're finding patterns in pie charts. And so it says for A, we're looking for a pattern. And so I'll give you guys about 1 minute to try to see if you guys can find a pattern or not for A. And so now we're going to go over problem A with A together. And so we'll try looking for a pattern. And so for A, if we have 8, 16, and 20, we multiplied 2 to get from 8 to 16, and then we added 4. So we'll see if that pattern is also visible in the second pie chart, or in the second chart. So we multiply 2, so 18 times 2 is 36, and we add 4. That gives us 40. So this is probably the correct pattern. So what we're going to do is we're going to multiply 2, so that gives us 66, and add 4, so we get 70. Then we're going to look at problem B. So to get from 24 to 3, we divided by 8 and multiplied by 7. But if we look at the second pattern, we see that 66 divided by 8 is not 9, so this pattern is not correct. But using the same pattern, we'll see if 21 divided by 7 is 3. So we divide by 7. And also in this pattern, 63 divided by 7 is 9. So we are dividing from the area on the top right to the bottom. But what would we do from this one? So from 3 to 24, to get from 3 to 24, we multiply 8. But again, we know that that's not the case for 9. And so we need to look for a different pattern. And one way to do that is, we don't always have to go like this. So another way that we can think of this is we add 3 to 21. And we add 3 to 63, and that does give us 66. So this is our correct pattern. Now then, since we had to divide by 7, that means we're multiplying 7 this way. So 10 times 70 is going to be 7. 10 times 7 is going to give us 70. And then we're going to add 3 to 70, so that gives us 73. Now let's look at problem C. So we have 34, 31, and 26. So from 34 to 31, we subtract 3. From 42 to 39, we do subtract 3, so that part is probably correct. Then from 34 to 26, we subtract 8. From 42 to 34, we do subtract 8, so this is probably the correct pattern. And we also know that we add 5 this way. And so 55 minus 3 is going to be 52. And if we subtract 8, that's going to be 47. And 47 plus 5 is going to be 52. So we completed the pattern. Now we're going to look at problem 3. And so in problem 3, it says find the missing numbers. So we have 1 times 9 plus 2 equals 11. Then we have 12 times 9 plus 3 equals 111. Then we have 123 times 9 plus 4 equals 1111. So a pattern that we see here is it increases by 1, 12, 1, 2, 123, 1234. So we're adding a digit that's larger. So we have 1, then the next digit for the next number is going to be 2. Then for the next number, we're going to add another digit, and it's going to be 3. Next digit, 4, 5, and so on. And so the next number, next number for the first blank is going to be 12,345. And then we add another digit, and it's going to be 6 and 7, so that pattern is confirmed. Now we're going to look for patterns for other numbers. Now we know that we're constantly multiplying 9. And that's already written down. Then we have plus 2, plus 3, plus 4. So this is going to be plus 5. Then we have 6, 7, 8. So that is also confirmed. And then, we filled in all the blanks. So we're now going to look at the blanks for the results. So again, it's increasing by one digit. So it's 11, 111, 1,111. 11,111, and so on. So in the answer right above the blank, we have 6 ones, so we're going to have 7 ones. We have 7 ones here, so we're going to have 8 ones here. Now let's take a look at problem 4. So it says, find the 4th, 7th, and 8th terms in the number sequence below. So from 1 to 5, we add 4. From 5 to 14, we add 9. Then, assuming that we're adding 5 for each of the numbers we're adding, we would add 9 plus 5, so that's going to be 14, and then the next one is going to be 19. And so, since the 55 is the closest number we know right after 14, we're going to check if this pattern is correct. So 14 plus 19 is going to be 33, and so 14 plus 33 is 47, but we should get 55. So we know that this pattern would be incorrect. Now another way to think of this is we add 4 and we add 9. And 4 and 9 are both square numbers. So this is 2 times 2, 3 times 3. So the next one would be 4 times 4, which is plus 16, and 5 times 5. And so again, we're going to confirm if that is correct by looking at 55. So from 14 to 55, we should have added 16 and 25. And that does give us 55, so we can confirm that this pattern is correct. So 14 plus 16 is going to give us 30. And then after that, we're going to do 6 times 6, so we're adding 36 to 55, and that does give us 91. Then we're going to add 7 times 7, so we're adding 49, and that gives us 140. And then we're going to add 8 times 8, so we're adding 64, which gives us 204. Now we're going to look at some more chart or figure pattern problems. So for problem A, I'll give you guys about 1 minute to see if you guys can figure out a pattern, and then we'll go over the solution together. And so we'll look at problem A. So we have 4 triangles here. And so now we have 10 in the middle, and so we'll see what we can do. So we have 3 problems. So we do need to look at all of them. And so it says find the values of A and B. So from 18 to 16, we subtract 2, but that doesn't work here, so we're not going to do that. And from 10 to 16, we add 6. From 22 to 18, we're not adding 6, so also that doesn't work. So basically, finding patterns is initially a process of trial and error. And so for A, it might be a little hard to figure out the answer at first because we can't really see like a clear pattern, especially because we have more than 3 numbers. So right now we have 4 numbers, which makes it even more complicated. And so to figure out a pattern for this, for A, I'm also thinking about the pattern, so it's not easy, you guys. And so for A, it would be 10 plus 18 is equal to 12 plus 16, right? So these two added together, 10 plus 18, so that's 28, that's equal to these two added together. Now let's check if that also works in our other problem. So we have 20 plus 22, but we cannot check. So we're going to look for, so assuming that these are going to be the correct pattern, 28 and 28, we should know that 34 plus A must be equal to 25 plus 15. And that tells us that 34 plus A must equal to 40, and so A is going to be 6. Now in this case, 20 plus 22 must be equal to 18 plus B, and so we have 42 equals 18 plus B, and B is going to be 24. B is going to be 24. Right, and so that was our pattern. I know it was a little tricky to find, especially because we weren't able to confirm our pattern, but that was the answer. And for B, 11 plus 15 plus 7 is going to equal the number in the middle. So the sum of the outer triangle is going to equal the inner triangle. Since 11 plus 7 plus 15 is equal to 33, then that tells us that A must equal to 8 plus 16 plus 10, and so A is going to be 34. Then for B, B is going to be 9 plus 14 plus 12, which is going to be equal to 9 plus 26, so that is equal to 35. So B is 35. Now we're going to look at C. So for C, we know that 8 times 3 times 1 divided by 2 is equal to 12. So what that tells us is we multiply the numbers in the outer triangle, divide it by 2, and we get the inner triangle. We'll test and see if that's correct using the third triangle. So 2 times 3 times 5 divided by 2 is 15, so that pattern is correct. So A is going to be 3 times 4 times 5 divided by 2, and so that is going to give us 30, and A equals 30. Now let's move on to problem 6. So problem 6 says find the missing numbers, and so for problem 6, we have an increasing number, so 1111, so this blank is going to be 11,111. And then here we also have the same pattern going on for the second number. So the second blank, the blank in the second column is going to be, since there were 6 ones, now in this blank there should be 7 ones. And then for the product column, we have 121, 12,321, and then the numbers are increasing by a lot, and so we're going to figure out a pattern from there. And so, of course, we can just get the number by multiplying, but we want to get the answer by figuring out a pattern. And so we see 1, 2 being repeated at the front for every single number. But then we have 1, 3, 3, 3. So it's kind of hard to figure out a pattern using this. And so if you look carefully at the numbers, we see it's 1, 2, and then goes back to 2 minus 1. It's going to be 1, 2, and then back to 1. Then here we have 1, 2, 3, and then it's going to go back down to 2, 1. So it's 1, 2 goes back down, 1, 2, 3 goes back down. Then we're going to see if that pattern continues. So we have 1, 2, 3, 4, right? So since above we went until 1, 2, 3, now it's going to go up to 1, 2, 3, 4, but then it's going to come down. So it's going to be 4, 3, 2, 1. So we can kind of divide it by looking this way. So we have our first 1, 2, 3, 4, and then it comes back down to 4, 3, 2, 1. And for the next one, we're going to add up till 5. So we have 1, 2, 3, 4, 5, and then we're going to come back down to 5, 4, 3, 2, 1. Then for the next one, we should go up to 6. So we're going to have 1, 2, 3, 4, 5, 6, then come back down to 5, 6, 5, 4, 3, 2, 1. Then we have 1, 2, 3, 4, 5, 6, 7, and then comes back down, 7, 6, 5, 4, 3, 2, 1, 3, 2, 1, and so we're going to go up to 8 now, so we're going to have 1, 2, 3, 4, 5, 6, 7, 8, then come back down, 8, 7, 6, 5, 4, 3, 2, 1. Now we're going to look at problem 7, and so in problem 7, we have 8, 5, 4, 7 in the beginning. Then we have 13, 26, so we're adding by 13. So you can think of this as adding by 13 or multiplying by 2, but if we look at the next one, we have 39. And so we added 13. Then one way to think of this is if you look at the ends, it's not in order. So if you think of putting this in order, the next number that would come after 222,222 would be 333,333, right? And then so if this row was over here, I'm going to see if that's a pattern, then that would be correct. So we're adding 13. And so for every 111,111 added to the product side, we're adding 13 to the second number. And so to get from 222,222 to 666,666, we added 444,444, which is 4 times this number. And so that means for this blank, we should have added 13 4 times. So we're going to do 13 times 4, which is 52. And so 52 plus 26 is going to equal 78. And then to get from 666,666 to 888,888, we added 222,222. So we're going to add 13 times 2, which is 36. And so that is going to give us 75. Oh, sorry. So we're not adding to 39. We're adding to 78. Sorry. So we're adding 78 and 36, which gives us 100. Well, not 36. I'm sorry for the confusion. We're adding 26, and that's going to give us 104. Now we just add 13 to 104, and that gives us 117. And then so now we have 65. So 65 is going to be 13 subtracted from 78. So we're going to subtract 111,111 from this number, and that's going to give us 555,555. So this problem was a little tricky, but we did solve it. So we'll go on to the next page. So it says complete the number patterns, and so now we're adding 1, 2, 3, but then now we're adding 5. So instead of thinking it like that, we're going to think of it as we add 2, 3, 5, then we add 8. And so that pattern might seem a little odd, but then now if we look at if we look here, we're adding 1. Then from 3 to 5, we're adding 2, add 3, add 5, and we add 8. And so what we're doing is we're adding these two together, and then that becomes 3. If we add 2 and 3 together, that becomes 5. If we add 3 and 5 together, that becomes 8. And so now we're going to add 8 plus 5, which is 13. So the next number is going to be 34. And then we're adding 13 and 18, so we're going to add 21, so we have 55. Then for the next sequence, we have 1 to 4, so we add 3, add 5, and add 7. And so we're adding 2 to, so we're skip counting the number that we're adding. So the next number we add is going to be 9. So we're going to have 25. Then we're going to add 11, so we have 36. Then we're going to add 12, so we're going to have 48. Well, that is, I guess, another way to look at the pattern, but instead the actual pattern for problem B. If that was confusing, I apologize, but we're just looking at multiple ways of trying to approach this sequence. But then I guess another easy way to think of this sequence is it's all perfect square numbers, right? 1 times 1, 2 times 2, 3 times 3, 4 times 4. So the next is going to be 25. The next is going to be perfect square of 6 and perfect square of 7. So that is the correct answer. Then we're going to look at sequence C. So we're going to look at it in terms of odd and even terms. 6 plus 2 is 8 plus 2. So the next time we're going to add 2 again. So we're going to get 12. For the odd numbers, so for the odd terms, what I mean by term is first term, second term. For the odd terms, we added 2. For the even terms, we also add 2. So we're going to have 7 and 9. Now for sequence D, we're adding 2, 4, 6. So we're going to add 8, add 10, add 12, and then we're going to add 14. Now for sequence E, we're adding 12. Then we're adding 24. Then we're adding 48. So the number that we add by increases by a factor of 2. So the next number that we're going to add then is going to be 48 times 2, which is going to be an addition of 96. So 96 plus 92 is going to give us 188. Then the next number we add is going to be 96 times 2, so we're going to add 192. So 192 plus 188 is going to be 380. Now the next number we add is going to be 192 times 2, so that is going to be 384. And so adding that to 380, we get 764. Now those are basically how we solve these types of problems. And so since we have a lot of problems to cover, I want you guys to try solving problem F, G, and H on your own. So you guys can pause the video right now and try solving. So I'll just write down the solution right now so that you can check whether your answer was correct or not. But I want you guys to try solving this before looking at my solution. So those are the solutions written in blue, but I want you guys to pause, have a go yourselves, try it out, and then check if your answer is correct using this solution. Now we're going to go and solve some practice problems. And so for problem 9, it says, what are the numbers in the 8th group in the pattern below? So in this pattern, we have 1 times 3 equals 3, and 3 plus 3 equals 6. 2 times 3 equals 6, 6 plus 3 equals 9. 3 times 3 equals 9, and 9 plus 3 equals 12. So for the 8th group, so for each group it starts with 1, 2, 3. So for the 8th group, it's going to start with 8. So we're going to multiply 3 and get 24. We're going to add 3 to 24, so we're going to get 27. So the 8th group is going to have 8, 24, and 27. That is our solution. For number 10, we have 1, 4, 8, 2, 8, 12. So 1 times 4 is equal to 4, and 4 plus 4 is equal to 8. 2 times 4 is equal to 8, 8 plus 4 is equal to 12. 3 times 4 is equal to 12, and 12 plus 4 is equal to 16. And so for the 12th group, it's going to start with 12, multiply 4, so it's going to be 48, and add 4, so we get 52. Now on the next page, we have find the sum of the numbers in the 50th group in the pattern below. So for this pattern, so we have 1 plus 1 equals 2, but 2 plus 4 is not equal to 12, so we're going to look at how to approach this problem. And so one way to think of this is we're going to multiply the first number to itself. So we're going to take the square of the first number to get the second number. Right, 2 times 2 is 4, 3 times 3 is 9. So we take the square of the first number to get the second number. But then to get to the third number, then what we do is we multiply the second number with a number that is 1 greater than itself. So we're going to multiply it by 2, since 1 plus 1 is 2. That gives us 2. So 4 times, so we're going to multiply the second number to a number that is 1 greater than itself. So I think I misread some numbers. So to get to the third number, we'll try again. So to get to the third number, what we do is we have 4, 12, 9, and 36. So what we can do is, so for now, since we're looking for the 50th group, we'll just figure out the first two numbers for now. So we start with 50, and we're going to take its square, so it's going to be 2,500. So now we're looking for the third number, and it's a little hard to find the third number, so while I think about the problem as well, I'll give you guys about 1 minute to solve. I'll give you guys about 1 minute to try to figure out the third number yourselves as well. Oh, and so, yeah, I'll still give you guys 1 minute, but to give you guys a hint, you should, instead of trying to think about going from the second number to the third number, I want you guys to think about going from the first number to the third number instead. I think that's a really big hint, so I'll give you guys about 1 minute from now. And so we're multiplying the first number to a number that is 1 greater than itself. So 1 plus 1 is going to be 2, so 1 times 2 gives us 2. I'll rephrase what I said. So we multiply the second number to a number that is 1 greater than the first number. So I know it's a little complicated, but so 1 greater than the first number is 2, so we're going to multiply that together. 1 greater than 2 is going to be 3, and so we multiply that with 4 to get 12. Now 1 greater than 3 is going to be 4, and we multiply 4 and 9 to get 36. And so in this case, 1 greater than the first number, 50, is going to be 51. So we're going to do 2,500 times 51. And so that is going to give us 127,500. And now we'll take a look at problem 12. And so we're adding odd numbers, so this is going to be plus 7. Then we have square numbers, perfect squares. So this is going to be 5 times 5, which is 25. And so this is going to be 6 times 6.